say we have a limit given by limit x approaches infinity, and then 8 minus x, not 8 minus 8x minus 5, 8x minus 5 divided by 2x plus 3. Okay, let's see what's going to be the value. And here, one way you can see it is you can remove the insignificant terms. When I say insignificant, like these constant values are insignificant. How can I say that? Like, for example, if I put 1000 for x value, because x is reaching infinity in a very large number. So when you have a very large number multiplied by x, the 5 is very small value. So we can neglect those things. That's why we call this one insignificant. If you remove insignificant values, we are going to get like 8x over 2x. That's going to be 4. So this is, we can directly see that one. But if you want to prove it, there's one way to do that. Let's go ahead and do this. So limit x approaches infinity. I erase this one and derive the answer using this method. Okay. Okay, let's go ahead and continue. So here limit x approaches infinity. What I'm going to do is I'm going to multiply by 1 over x, because we have x here. So we can multiply by 1 over x. If we have x square in the numerator and denominator, we have to multiply by 1 over x square. So it depends on the power of the x. So here we are going to multiply the numerator and the denominator by 1 over x. 8x minus 5 divided by 2x plus 3 multiplied by 1 over x. And if I do it in the numerator, I have to do the same thing in the denominator as well. 1 over x. And if we simplify this one, this is going to be limit x approaches infinity. 8x times 1 over x, that's 8, minus 5 times 1 over x, that's 5 over x, and 2x times 1 over x, that's 2, and then 3 times 1 over x, that's 3 over x. Now we can go ahead and substitute the infinity for x values. So this is going to be 8 minus 5 over infinity. When you divide a number by a large number, that's going to be 0. So 5 divided by a large number, because infinity, 5 over infinity is 0, and then divided by 2 plus, again, if you divide a small number by a large number, that's going to be equal to 0. So 3 divided by infinity, that's also 0. So we get 8 over 2. So the final answer is 4. Now let's look at another problem. Let's say we have a question like this. Let's say we have a question like limit x approaches infinity. 5 minus 7x cubed. And in the denominator we have 3x plus 5x square plus 9. Let's put 5x cubed. Okay. Plus 9. Now here, how we can solve this one? Here also we can do the insignificant. Like, let me write this one clearly. Okay. 5x cubed. Okay. Here we can do the same thing as before. We can remove the insignificant terms. What are these insignificant terms? Whatever the highest value here, like in the numerator, the highest power is x power 3. So anything except the x power 3 in the numerator is insignificant. So this 5 is an insignificant. And in the denominator, we have 5x cubed. So again, x power is 3. The highest power is 3. So this 3x and 9 are insignificant. So we will get negative 7x cubed divided by 5x cubed. And that's going to give us negative 7 over 5. That's going to be approximate answer. Now let's go ahead and prove that one, doing by steps. Okay, so I remove this one. Okay, now here you can see the highest power is x cubed, so we have to multiply the numerator and the denominator by 1 over x cubed to solve this problem. So let's go ahead and do that. Limit x approaches infinity. 5 minus 7x cubed multiply by 1 over x cube, and then divided by 3x plus 5x cube plus 9 multiplied by 1 over x cube. And if I multiply that one, we will get limit x approaches infinity 5 over x cube minus 7x cube times 1 over x cube, that's 7, divided by 3x times 1 over x cube, that's going to be 3 over x square, plus 5x cube times 1 over x cube, that's 5, plus 9 times 1 over x cube, that is 9 over x cube. Okay, now whatever the values that are dividing x, so x power something is going to be 0, because all of those are dividing by infinity. So we can substitute the infinity for these things and solve this. So 5 over infinity cube, that's going to be 5 divided by large number, so that's 0, minus 7 divided by 3 over x square, 3 divided by large number, that's 0, and then plus 5, 9 over x cube, 9 divided by a large number, that is also 0. So from this one we derived negative 7 over 5 as our final answer. That's our final answer. Now let's look at another problem. I'm going to go ahead and erase these things. Okay, let's try this one. Let's say we have a function given like limit x approaches infinity square root of 16x square minus 8 divided by 2x minus 5. Evaluate this function. Now here again we can remove the insignificant and solve for this one. Like insignificant, if you look at the numerator, the insignificant is 8, because when you have x square, for example, if you put 100, the 100 square is like 10,000. 8 compared to 10,000 is a very small number, so that's why we can neglect these numbers and just bring the highest power. So here 16x square is the highest power in the numerator, so anything except that is going to be insignificant. So we can just write like square root of 16x square, and in the denominator 2x is the highest power, 2x is the x power highest power, right? So this negative 5 is an insignificant, so we can get rid of the negative 5 and just write 2x here. And if you square root 16x square, that's going to give you 4x, and that one divided by 2x, that's going to give you 2. Now this is shortcut to find out, but let's go through steps. Okay, so I am going to remove this one and let's go through steps. Let's see if we are getting the same answer. Now to find out steps, like first you have to see what's the highest power here, x square and the x, but x square is basically x outside of the square root, because if you square root x square, that is basically x. So we have to just multiply the numerator and the denominator by 1 over x. So this is going to be limit x approaches infinity, and we multiply the numerator and the denominator by 1 over x, 2x minus 5 times 1 over x. Okay, now let's go ahead and simplify this one. Limit x approaches infinity, and here you can see, like if we have 1 over x outside, we cannot do anything with this function. So what we can do is we can bring this one inside of this square root. If I bring the 1x inside of the square root, that's going to be 1 over x square. So we are going to multiply this 16x square minus 8 by 1 over x square, and in the denominator we can simplify that one. 2x times 1 over x, that's 2, minus 5 times 1 over x, that's 5 over x. Okay, now let's go and simplify here. So here we can multiply the x square with both terms. So if you do that, this is going to be limit x approaches infinity square root of 16x square times 1 over x square, that's 16, and then minus 8 times 1 over x square, that's 8 over x square. And in the denominator we are going to have 2 minus 5 over x. Now we can go ahead and substitute our x value, that's infinity. If we do that, this is going to be 16 minus 0, because if we here we have 8 divided by x square. So x square is basically infinity square. Infinity is a very large number, and if you divide 8 by a very large number, that's going to be 0. So this is 0 right here. And then 2 minus 5 over x, again 5 divided by a very large number, that's also 0. So we are getting 0 here as well. So if you square, so this is going to be square root of 16 divided by 2, and square root of 16 is 4. 4 divided by 2, that's equal to 2. That's our final answer. And that's it for this video, guys. Thanks for watching. See you guys on my